I'm going to be talking about, I'm going to give you a little background of the Voice of America, a little bit of the history, actually quite a bit of the history of Voice of America, where they came from, how they got started, and what they're all about, and how Collins Radio, this is the important part of this talk, the association with the Collins Radio Company. And Collins provided actually more than just these transmitters that I'm going to talk about. They provided a lot of equipment to Voice of America over the years. So here we go. What is the Voice of America? Well, Voice of America is the official U.S. federal government external broadcast entity. What does that mean? It means the materials that are presented by the Voice of America are meant for foreign audiences rather than domestic audiences. And you're going to hear some interesting stuff about that, because I, like me, many of you out there in the audience have probably listened to the Voice of America. I used to listen to the Voice of America when I was a kid, and I used to listen to this station until it went off the air. So it may be intended for foreign audiences, but the domestic audience gets it anyway. So it's just kind of funny. It's operated under what is called the United States Agency for Global Media, the USAGM. It used to be under something called the U.S. Information Agency. That changed a few years back to this new one, USAGM. Voice of America is one of 5 civilian U.S. international broadcasters, and it's considered a civilian broadcast organization. So you've got the Voice of America. We've got Radio Free Europe and Radio Liberty, which is one of the 5. We have Radio Marti, actually Radio and TV Marti, which is targeting Cuba, Radio Free Asia, and the last one is the Middle East Broadcast Network. So these are the 5 civilian U.S. international broadcasters. And these broadcasters provide programming in radio, TV, and on the internet. They produce about 1,800 hours of programming material weekly in 47 different languages. And it's estimated that their global audience is in excess of 278 million people. And they still maintain 19 major transmitting sites around the world. We're going to be just talking about one of those eventually, but talk a little bit about some of those sites. Many of them are gone that they used to have, but today the Voice of America currently maintains shortwave and medium wave transmitting facilities. The first one is the picture there, which is located in Greenville, North Carolina, and that's the Edward R. Murrow Greenville transmitting station. So that's one that you might hear on shortwave. The other station that they maintain is a medium wave station on the island of Sao Tome off the west coast of Africa. And what's curious about that is the broadcast facility sitting right next to the Voice of America broadcast facility in Sao Tome is Radio Moscow. I love that. They're right next to each other. Well, the Voice of America formerly had a number of other sites. Some of you may be familiar with some of these. Bethany Relay, which is located near Cincinnati, Ohio. Located here in California, of course, what we're going to be talking about today is Delano Relay, which is located off of Highway 99 between Bakersfield and Fresno. And the other one is more northern California towards Sacramento, is the Dixon Relay. Those 3 stations are now off the air. They have been for some time, but other stations that they had, broadcast facilities that are also off the air now, are located in Hawaii, Okinawa, Liberia, Costa Rica, and Belize. Those are all gone. So it's down to that one shortwave broadcast facility in North Carolina now. So a little bit of their history. Prior to 1939, all United States shortwave stations were privately owned. They were owned by some of the major networks like NBC. NBC owned what they called the International or White Network, and they broadcast in 6 languages. CBS owned 64 stations located in 18 different countries, and they operated those. Old Crosley, if you guys are familiar with Crosley and what is WLW out there in Ohio, probably one of the most powerful broadcast stations ever built. Crosley had 12 experimental transmitters located around various places. The problem with all of this is that that there was no policy for content of these broadcasts that were intended for foreign listeners. And that created a problem for our government. And of course, 1939 what's happening. It's the advent of World War II in Europe. This is all starting up. So the actions that took place in Europe after 1939 forces the FCC to create a new policy. And the policy states, and I highlighted the pieces here that I think are important, that this new policy reflects the culture of this country to promote goodwill, understanding, and cooperation. Now, what's interesting is this has no effect on domestic broadcasting. Now, it's not targeting domestic broadcasting, and it's only affecting the broadcasts that are being sent out internationally. That's the key. The State Department had created something called a good neighbor policy, and this is what they were with the FCC creating this new policy for broadcasts. They liked that because it was in line with the good neighbor policy that the State Department had developed. Well, the broadcasters see this as censorship, naturally. It is, and it's really what it was. It was censorship. Well, 1940, they created something called the Office of the Coordinator of Inter-American Affairs. And this was an independent agency that was created under the US Department of State. And its purpose was to basically monitor these broadcasts. And in particular, they were interested in shortwave broadcasts to Latin America. Why was that the case? Well, it was considered that was vital to counter the Nazi propaganda coming out of Europe from Germany, large presence in Latin America and South America. That's where these broadcasts were now targeting. And what was happening was that these broadcast stations, and these are the civilian broadcast stations, like I mentioned, the NBC, the CBS, and the Crosley stations, they received media releases from OCIA that they were intended to broadcast. Well, overall, it was considered that this system was very inefficient. And out of this inefficiency of having to rely on these other civilian broadcasters, the Office of the Coordinator of Inter-American Affairs created, and the State Department created, the Voice of America. So the Voice of America came into being as Voices from America. Voices from America first went on the air on February 1st of 1942, and the first broadcast was directed towards Germany. And it was called Stimmen aus Amerika, which is Voices from America. And the first thing, this was their first statement when they went on the air, was this quote, basically saying, we're going to tell you the truth. It may be good for us, it may be bad for us, but we are going to tell you the truth. Of course, at this time now, World War II, we're engaged in World War II in Europe and in the Pacific Theater. And so Voices from America was taken over by the Office of War Information, OWI. So State Department was no longer controlling it. Pardon me. So now with World War II, VOA doesn't have any transmitters of their own. Commercial transmitters are shut down. The broadcasters are being shut down. They're not allowed to broadcast at all. So the VOA, at least here in the United States, let's put it that way, there was a shutdown of, amateur radio was shut down. The commercial broadcasters were shut down. So the VOA started using transmitters in Europe that belonged to British Broadcasting Company, BBC. These are medium wave transmitters that they had in England. And as the war progressed, we were able to create new transmitting facilities in Tunis, Palermo, and Bari. And what the Office of War Information did was they established something called American Broadcasting Stations. So this was European theater. Now in the Pacific Theater, a little different situation. The Pacific Theater, the VOA was able to basically take over a commercial transmitter here in California in 1941. And they used that to broadcast into the Pacific at that time. And eventually they built transmitters in Hawaii and in the Philippines as the war progressed. So we had facilities closer to Asia at that time. So at the war's end, VOA had been busy. They had 39 transmitters worldwide, and they broadcast in 40 languages. But of course, with the end of the war, they no longer needed those 39 transmitters. So they started shutting down some of those facilities. So by 1945, roughly half of the services had ended. So late in 1945, the Office of War Information transfers the Voice of America back to the Department of State. So it's back where it started. So what happened after World War II? We entered the Cold War. Now what's going on? We're waging a propaganda war with the USSR, the Soviet Union. So by 1947, the VOA is now targeting the propaganda coming out of the USSR. We're countering the Soviet propaganda. Well, it wasn't long, basically 2 years later, that the Soviets began jamming the broadcasts. So how does the VOA get around the jamming situation? They're trying to get into Europe, which is behind the, basically trying to get behind the Iron Curtain, into Europe and China and places like that. They started something called Operation Vagabond. Now, Operation Vagabond is fascinating. They basically commissioned a U.S. Coast Guard cutter called the Courier, and it was actually operated by the Coast Guard. This was a shipborne broadcast and relay station. And here's a little photo of it. And in that photograph, you can see some of the antenna rigging here. This is HF antennas. They had HF transmitters and medium wave transmitters. The medium wave transmitter was a wire antenna at one time, eventually strung between the two masts here. But at the outset, when they started operating, they used some leftover surplus barrage balloons leftover from World War II. And they'd hoist a long wire up in the air with a barrage balloon, but they kept losing them. So that's when they went to going to the like a delta loop configuration antenna between the masts is what they eventually went to. Well, this ship operated for 12 years. And it has, to this day, I believe it still has the distinction of being the longest deployed away from the United States ship in our armed services, with the Coast Guard, Navy, whatever. 12 years deployed, never touched US soil. So pretty amazing. Well, there are a couple of other interesting records about this ship. You're familiar, back in the 60s, there were lots of pirate radio stations off the coast of England, but these weren't really high power stations. They were, typical broadcast station, maybe 25, 30, 50 kilowatts. This ship, the Courier, had the largest medium wave transmitter ever installed on a ship. It was a 150 kilowatt RCA BT-105. Then you see that in the background in this image here. That's this guy right here. That's that BT-105. I like the fact that this operator has his feet up on the desk. That's me when I'm working. But this is the audio control console for the transmitter right here. And this is some other audio, probably the modulation monitors and things like that for the transmitters. So they had this 150 kilowatt BT-105. They also had two Collins 207B1 35 kilowatt shortwave transmitters. And that's what you see in that picture there is one of the 207B1s. So they were transmitting, like I say, both shortwave and medium wave. And this was Collins, I think probably Collins' first action with the Voice of America. But they also had a room full of 51J receivers that was basically their receiver control room. And this is where they received material coming from the studios in Washington, D.C. And you can see in this photograph, there's some interesting things in this photograph. This was actually a press release photograph of the control room for the Courier. You can see the racks of the 51J4s here. There's a bunch of them. But what you see here in the foreground are some transcription lathes for cutting transcription records. They would receive the audio via these 51J receivers, as well as the SP600s that you see there. They would go to this cutting lathe and create a transcription record, which would then be carried to another turntable to rebroadcast that information. So that's kind of a neat little picture of the ship there. I recently ran across this on Facebook, believe it or not. I found this, somebody had posted this photograph and I found it later online, but this is I found the press release that went with this. It's an interesting story on the Courier. So after 12 years, the Courier was decommissioned as a Voice of America broadcast ship, and it was returned to the Coast Guard, and it eventually became a training vessel until it was decommissioned. So out of all this was the creation of the USIA, and this is the one that I remember from when I was a kid, that listening to Voice of America as being part of the United States Information Agency. Again, it was was established in 1953 by President Eisenhower, and USIA operated and up until 1999, and they actually were reorganized and a new organization was created. We'll talk about that. But USIA was there in 1999. And here's their mission statement. And there we go. It's to understand and influence foreign publics in promotion of the national interest, and to broaden the dialogue between Americans and US institutions and their counterparts abroad. It's a great mission statement. Again, it's not targeting domestic audiences. It's all for international audiences. So I want to talk a little bit about their role, USIA. What came out of this in 1948 was something called the Smith-Mundt Act. And the Smith-Mundt Act established
Sorry. That's right. You look pretty tired. I just went up and did it.
We need to mute a microphone there somewhere, guys. Anyway, there's no domestic dissemination of foreign target propaganda. So think about that. Here's the Voice of America broadcasting on shortwave and medium wave, and this Congress passes this act, which Harry Truman signed into law in 1948. No domestic dissemination of foreign target propaganda. And I love the fact that they use the word propaganda, because that's exactly what it is. What their intent is that Congress, the media, and academia would filter this broadcast material for the domestic audiences. So essentially what it did is it forbid the Voice of America to broadcast to the United States audience. Well, listen, anybody with a receiver, a shortwave receiver, could listen to Voice of America. In the 60s, I did, for crying out loud. So, I don't know that what really was all about control, and having Congress being able to control what USIA would broadcast. And USIA was charged with control of that material as well. So it basically placed 3 restrictions on broadcasting by Voice of America. It prohibited the domestic dissemination of materials. I mentioned that. And it also placed, it actually prohibited the Department of State and USIA from acquiring a monopoly on broadcasting. So they forced them to rely on private agencies for domestic broadcasting. That was the deal. So in other words, the media. So they were insulating the American public from being targeted by government-sponsored information. What a kick. I love it. So in 2012, the Smith-Mundt Act was amended, and it took away that restriction on dissemination to US. Well, think about it. The Voice of America is on the internet. The Voice of America is broadcasting over shortwave radio up to that time. And anybody with a shortwave radio anywhere in the world is going to be listening to it. Well, one of the interesting things about the Voice of America, believe it or not, it is the world's largest full-service public relations organization. Think about that. It is the world's largest full-service PR organization. The USIA does create their materials. And of course, this is what I love. They've got a $2 billion annual budget. USIA has a $2 billion budget. And at the time of the Cold War, their chief adversary, the USSR, they were responsible for the propaganda war going on between the United States of America and the Soviet Union. And they were waging that war in 150 different countries. So after the fall of the Soviet Union, post-Cold War, things changed a bit, right? So the Voice of America starts adding new language broadcasts. We're not being jammed by the Soviet Union because the Soviet Union doesn't exist anymore. So VOA adds a bunch of new languages. And one of the interesting things that happened is in 1993, President Bill Clinton proposed cutting Radio Free Europe as it wasn't needed anymore. Well, it was not well received. So you'll see, I showed you the 5 civilian broadcast entities. that comprise the agency under the Department of State, Radio Free Europe is gone, and it was shut down, but it was replaced. So we still have it's like things like Radio Liberty and the like. But then people weren't happy about Radio Free Europe being shut down. But what they did do is they created something called the International Broadcasting Bureau. So this is where the USIA forms this thing called the IBB, and it was established in 1994 under something called the International Broadcasting Act, which was tied into the stuff that Clinton was doing at that time. And this is part of the USIA still, the US Information Agency. And they created something called the Broadcasting Board of Governors. Now, the Broadcasting Board of Governors are the guys that ran the Voice of America transmitter sites, including the one in Delano. When you go up, if you go up and visit the Delano site, which is still standing, there's a big sign out there that says that it's under the auspices of the Broadcasting Board of Governors. That's who ran that site. In 1998, they had yet another act by the government, Foreign Affairs Reform and Restructuring Act. And at that time, the Broadcasting Board of Governors became an independent federal agency, and the USIA was abolished, and all the functions go back to the Department of State. So that was kind of an interesting little turn of events there. So what happens with USIA and the Voice of America? So Voice of America was the broadcast division of USIA, and primarily radio, as we said, shortwave and medium wave broadcasts, but they also do television now, but their main target was listeners behind the Iron Curtain. We knew that. Their charter had been established in 1960, and I mentioned that before. We saw that. I put that little blurb up there. But by 1967, they were broadcasting in 38 languages, 26 million listeners worldwide. Pretty big audience in 1967. But now, I said, after the fall of the Soviet Union, the end of the Cold War, what are they doing now? What is the Voice of America doing today? Well, they've primarily gone to internet and satellite services, but mainly internet. Believe it or not, the Voice of America was the first broadcast news organization on the internet in 1994. I think that's kind of an interesting milestone. And today, they broadcast in English and 44 additional languages worldwide. Their internet presence consists of 20,000 servers located in 71 different countries worldwide. Well, why has this happened? Why did the broadcast facilities go away? Well, it's the impact of technology. The proliferation of the internet, of course, has put an end to a lot of shortwave broadcasting. And if anyone who is a shortwave listener, whoever was a shortwave listener, if you do that now, you note how the scene has changed in shortwave broadcasting. We don't see what we used to see in there, all the broadcast services. But the Voice of America did maintain their broadcast services in Africa. I mentioned Sao Tome. And the broadcast facility in North Carolina is, I think, primarily targeting Cuba. I think that's their target audience with Radio Marti. But much of those medium wave and shortwave broadcasters no longer exist. So they're gone. They are gone. But we're going to talk about the one that's here in one of the ones here in California. Let's start talking about Delano a little bit. Voice of America Delano. This is what you see. It's kind of a grayed out image, but that's the view from the front gate as you enter the facility at the Voice of America Delano Relay Transmitting Site, as it's officially called. The relay site broke ground in May of 1944 during World War II. And there's an interesting story about that the Voice of America, I mentioned before that they were using a commercial. They basically commandeered a commercial broadcast station here in California, which I believe was in the Bay Area, and I'm not sure who it was, but I believe that it was something up in the Bay Area. I'm kind of sketchy on the facts about that one, but I do know that it was in California. So they were relying on someone else. Well, the Voice of America decided that they want to build their own broadcast facility, or actually a relay facility, and I'll explain that shortly, what a relay facility is, because it is actually different than a broadcast facility. But they wanted to have their own facility. So they started going around California, looking at different locations. And one of the locations they were thinking about was out near Mojave. The problem in California was that land was expensive. Even the land out by Mojave in 1944 was pricey for them. Well, one of their surveyors happened upon Delano in this core of the Central Valley and realized with their RF engineers, their RF engineers looking at this site, realized that this is the perfect location. It's got mountains around it, but they're way off in the distance. We get low angle radiation away from a transmitting site. The land is cheap. It's basically, there's a lot of farmland, but a lot of available land around that area north of Bakersfield, south of Fresno. They ended up buying, and it was some ridiculously low amount of money, like pennies per acre, 800 acres of land just west of the town of Delano. So they broke ground in May. Dig this. By November, they were on the air with their first rhombic antenna 170 feet up. That's pretty good. Try doing that today. You'd have to get all the variances and approvals and oh man, it'd just be crazy trying to build a site like that today. But May to November, they were on the air. That's amazing. Well, Delano was the first of the 3 relay stations that they built. I've mentioned these before. The others are located in Dixon and Bethany, Dixon, California, and Bethany, Ohio. They also they also established a receive site a few miles up the road, up Highway 99, in the little town of Pixley. I love that. Right next to Hooterville. But Pixley was a receive site. And as far as I know, the receive site was never needed because all the program material was sent from Washington, D.C. to the Delano, Dixon, and Bethany sites via AT&T landline, what used to be called the long lines system. So it was all over terrestrial links, and that's how they sent the material. Well, I'm sure they tested the receive site, but it sounds like they never actually used it to carry their broadcast material over to the Delano site. Well, October 27th, 2007, at 8:30 p.m. in the evening, they pulled the big switch at VOA Delano and they shut down. The last scheduled program was on 5,890 kilohertz and it was in the Thai language. The sad part is that there was no special observation of the 63 years of continuous service that station did. 63 years of continuous operation, and not a word was said. The place was basically just locked up. People walked away. And that was the interesting thing, that when we went there, it looked like just people had just stood up from their desks and walked away. And everything was left as it was. It was pretty remarkable. Now there was some jumble of stuff, and I will talk about that a little bit. But it was pretty remarkable to see the things that we saw there and the things that we found. Well, I'm going to share some photographs of the construction. This is I talked about the rhombics. The rhombics were the first antennas to go up, but this is part of there's 2 bays of. Well, there's actually 8 bays. There's 3 towers that are roughly 200 feet tall that hold a multi-bay, what's called dipole curtain array. And I'll show you a picture of a dipole curtain array shortly so you can understand what this is. But these are monstrous antennas. They're basically tunable. They're steerable. You can change the direction. You can change the angle of takeoff by changing the phasing between the elements. It's just a bunch of, if you think about a cage dipole, think of a bunch of cage dipoles arrayed set up in a huge array that allows you to connect to each dipole individually and change the phase between those antennas. And that's kind of the idea of the array. The curtain is a ground plane that's hung behind the dipoles, the dipole array. So that's why it's called a curtain array. You have a ground plane, and so the energy is directed in one direction away from the antenna array. So this is one of the footings being constructed and one of the towers being erected. And this is a ground level view of the facility. at that time when it first went on the air. And you can see that curtain array in the background. You can see the catenary cables between the towers, and those are supporting these dipole arrays between them. And you can see the towers from the rhombics at that time in the background. So that's the station at the time of when it went on the air, or shortly thereafter in the 40s. In the early days, they had their early day transmitters consisted of these. There was a federal 200 kilowatt transmitter. There were 3 RCA 50 kilowatt transmitters, and eventually they added 2 General Electric 100 kilowatt transmitters. Now these pictures are of the early control rooms, and you'll notice this is the earliest one. And look what's here. Here are those transcription turntables. This is essentially what those lathes. They would have had a room here with the lathes where they're receiving the material, cutting it up to a disc, and then taking the disc to these transcription turntables to broadcast the information. Well, I should say relay the information. And this is the control console for the RCAs and the federal transmitters in the background here. Now, eventually, they went to reel-to-reel tape, and so you see this same setup here with some revised equipment, upgraded equipment, but we see the Ampex reel-to-reel tape decks here, which was a change from the transcription turntables. Well, by 1964, the Voice of America realized they needed to do something else. They needed to be able to deal with the fact that their broadcasts or transmissions were being jammed by the Soviets. And I mentioned this is called a relay station. Why is this a relay station? This station itself was not intended for an audience. It was actually intended as a midway point between the studios in DC and the broadcast facilities that are located out in the Pacific and elsewhere. And in particular, this station was feeding out into the Pacific region. So the Philippines, Hawaii, what have you, where they had their broadcast facilities. So the relay mainly just took the recorded material, sent it to the other station where it could be re-recorded and then broadcast to the audience. That's the purpose of a relay station. Well, in 1964, they decided to contract Collins to build these 821A1s. And these are quite a fabulous transmitter. And I'll talk a little bit more about that shortly when we start talking about the details of the transmitters. But this is their expansion. And this comes out to the east side of the old transmitting facility. They built this new addition. Well, following Delano being shut down in 2007, the Voice of America transfers the ownership of Delano to the General Services Administration. And of course, the GSA is charged with finding a new owner for this property, whether it be a government owner or a private owner. They were looking at what to do with the property. They were thinking of turning it into a regional airport. They were thinking of turning it into low-income housing area. They also have a prison kind of catty corner from the site there in Delano. They were thinking of expanding the prison onto this property and using it for that. So the GSA is trying to sell this. Well, they'd already sold the Dixon site. That had been sold to a farmer, and the farmer made a killing on that because he was selling it. You can't imagine how much copper was located in those antenna farms. Lots of it. So Dixon's been sold to a farmer, and he's selling off all the scrap copper, making a fortune on it. Bethany was turned into what is now the Voice of America Museum. But what's happening with Dixon? Well, what happened with Dixon? Well, actually, this is kind of cool because the California Department of Fish and Game discovered that there was a endangered species located on the property, which was some kind of shrew. I can't remember what the exact name of the shrew was, but there's this shrew on the property. Because the shrew is there, they can't do anything with the property. They can't demolish it, which is essentially what they were going to do. They can't demolish it. They can't sell it to the city. They can't sell it to Delano to turn it into local income housing. They can't sell it to the state of California. They can't do anything with it. So it's just sitting there. It's still sitting there. They were going to drop the towers. They were going to demolish the buildings. They haven't been able to do any of that because of the shrew. Thank you, Department of Fish and Game. That was cool. Well, what happens? There's still the threat of the buildings being destroyed or demolished. So I didn't really mention this before, but I want to talk about the Collins Collectors Association. I am a member. I'm actually a member of the board of directors of the Collins Collectors Association. I'm the secretary. I also am a net manager for one of our weekly nets on 75 meters. And Collins Collectors Association, we are chartered with maintaining the lore of Collins Radio Company, which is now part of United. See, I guess it's United. I can't think of what they're United Technologies. I had to think about it for a second. Collins became Rockwell Collins, and then it went to United Technologies, which is where it's located now, and it's now called Collins Aerospace. But we wanted to preserve that history, and that's exactly what the Collins Collectors Association does, is we preserve the history of Collins Radio Company. And it's quite a legacy that we have to preserve. I am a devout Collins radio collector. I have sitting behind me in the ham shack a number of Collins S lines, KWM2s, KWM380s. Let's see, broadcast transmitters from Collins. I have HF80 systems, which was their last commercial shortwave system they made. I have a lot of their A line and S line gear. Yeah, it's just it's a sickness. Yeah, it's a sickness collecting Collins. But I am a member and director of the Collins Collectors Association. Well, a couple of our members, in fact, it was our president, who was Bill Carnes at the time, and Jim Stitzinger, who is our archivist. They got this idea over dinner one night that, hey, you know, there's a threat that this place is going to be destroyed, and these transmitters, these 821A1s, are kind of rare. It's one of a kind. They only made 9 of them. There were 3 located at each site. It was the largest broadcast transmitter that Collins ever made for shortwave broadcast, 250 kilowatt transmitter. So Jim and Bill, under the auspices of the CCA, the Collins Collectors Association, they seek out to obtain ownership of one of the 821s and transfer it for either display at the Collins Museum in Cedar Rapids or to the Antique Wireless Association Museum in New York. Why not? You know, let's preserve this thing. It's going to end up in a landfill if we don't. So they approached the VOA. The VOA told them, well, we don't own it anymore. It now belongs to the GSA. So you're going to have to go talk to them. So they go talk to the GSA. And the GSA says, well, okay, if you're going to put it in New York at the AWA, you're going to have to talk to the GSA in New York. So they contacted the GSA in New York because the Collins Museum really didn't want to put it there. I don't think they had the room for it. This thing's huge. You'll see that in a minute, just how big this thing is. We'll talk a little bit about the enormity of this project. The GSA New York finally agreed, but they put conditions on it. They said, we have to have the transmitter off the site within 2 weeks of start of taking it apart. 2 weeks. We got 2 weeks to take it down and transport it. Oh, and by the way, you've got to have it in the museum within 18 months on display to the public. Wow. Okay, so 2 weeks. Let me talk about the Collins transmitter. I just got this thing for Collins. Well, I guess I'll talk a little bit about our team first. So we're charged with under Bill and Jim to go to Delano, and we put together a team to go and tear this transmitter apart, take it to pieces, pack it up, and ship it off to New York. So in May of 2014, our team arrives in Delano, and it consisted of Bill, N70TQ, Jim, WA3CEX, and Jim brought one of his employees with him, Tim. I don't know Tim's last name, but he's not a ham. Vince Baker was another fellow that joined us. Vince was an employee of the Voice of America. He lived in Fresno and drove to Delano every day. That's about 100 miles. Well, it's not quite. I guess it's probably about 100 miles round trip that he would drive every day. And he wasn't really a technical guy. He was a finance guy with the Voice of America. So he'd drive down there, and he was basically our babysitter. But more on Vince in a while. He was an essential member of our team. Rod Bloxham, K0DAS. Rod was a retiree of Collins Radio, former engineer. I mentioned HF80. He was one of the chief design engineers on the HF80 system and was very familiar with the technology of the transmitters at the Voice of America, the 821s. So this was it was an opportunity for Rod to come out and join us. And with his knowledge, it was really wonderful to work with him. He was one half of the engineering team. Scott Kerr, who is now currently our president of the CCA, and another CCA member, Brian Garrick, KE6IYC, and Dave Jennings. Some of you probably know Dave. He lives down in the LA area, WJ6W, and is a big fixture on AM amateur radio here in Southern California and the West Coast. We also had somebody from the Southern California Antique Radio Society, a fellow by the name of Joe Knight, and I'm not sure what his call sign is. I know he was a ham. So they were involved. They helped us out. And of course, yours truly was the other half of the engineering team. But Rod was in charge. I worked for him. But my whole role was to document what the heck we were doing. So I had to label and document everything we took apart. Oh boy, what fun. So we begin the relocation of DL-8. So those of you, I'm sure some of you have been to the Delano relay site. Marty, before we started, mentioned the DX convention in Visalia. A lot of folks would stop by. The Voice of America actually gave tours at one time of this facility. So a lot of folks have probably seen this room. What you see in this room, and I'll point them out, these are a pair of Continental single sideband. These are Ssb transmitters. They're 15 kilowatt. No, they're 50 kilowatt Continentals. The Collins transmitters are located behind this doorway here, this doorway, and another one that's down here off to the left that you can't see. So there's a window here where you can actually see DL-8, which is behind this door. That's Rod Bloxham standing there waving at us. And this is the control room for the station. So it's got all the audio controls, transmitter controls, everything's located in this control room right here. So you notice we had to cut out the doorway. The doorway, as it was here, wasn't big enough to get the transmitter out, pieces of it. So we had to take a Sawzall and enlarge the door. Well, this is the front panel of the transmitter. This is just the front panel, and this is all the local controls for the transmitter. This is where the transmitter can be operated. It can be operated from this station, but it's typically operated in that little control room. As we walk around the transmitter to the left, you'll see there's a big cage. You can see the chain link there and a door that's open. The chain link houses the actual transmitter itself. And walking a little bit further, we've actually removed some of the chain link fencing by the time this photograph was taken. This is actually a harmonic filter and balun on the output of the transmitter. That's what these three sections are here. And if we start looking up in the air, you see what looks like maybe steam pipes or something. Those they're about 8 inches in diameter. The ducting there, that's actually coax, but the two of them form a balanced transmission line that feeds from this harmonic filter, which is this guy here, with the Collins logo on it. There's actually a balun that takes the single inlet output of the transmitter and turns it into this balanced line that comes out and goes into what looks like a piece of air conditioning duct that takes the balanced line, shielding it out of the building to be able to go out to the antenna farm. So that's this is the business into the transmitter right here. Now, if we continue on walking to the left, or actually in this case, turn to the right a little bit, this is looking between that front console and the harmonic filter. This is the actual power amplifier right here. That is the PA. That houses two 4CV 100,000 Cs. That is a 100,000 watt plate dissipation vapor phase cooled tetrode. It actually sits in a tub of water, and the water boils, carries away the heat to a condenser that's located up in the attic of this building, and returns it as cooled water back to the tub that the tubes are sitting in. These tubes are in parallel, but it's AM, so it's got a modulator, and this is the modulator itself. And the modulator is a push-pull modulator. That is a push-pull modulator. So you can see these are the two halves of the modulator. The tubs sit down here, and that right there is actually the top of the tube. That's actually the socket. The tube sits upside down with the socket on top. And to give you a better idea what this tube looks like, that is the 4CV100C. Now, I mentioned Vince Baker was an essential part of our team. So we're trying to figure out, we need to take these tubes out because we have to essentially disassemble this whole modulator to be able to move it. It's just too massive to move it the way it is. We have to really disassemble some major pieces of it. Well, we're looking at this tube, trying to figure out how to get the tube out of the socket down here. Here's the socket here. We were able to remove the socket, but the tube is down in here in this cavity. You unbolt it, but there's no way to remove it. There's no way to lift it, but we could see that there's this overhead track. We've got a track here. So I started looking at the manuals. We had a full set of manuals of this transmitter. I'm looking at the diagrams and the maintenance documents on the transmitter, and it talks about these trolleys, these little things right here. Well, we didn't see any of it. We're looking around, we can't see any of it. We don't know where they are, but that's how they get removed. It's got a little winch and a cable. The cable twists into the socket on the tube, and you lift the tube out of the cavity down there. Well, I happened to be talking to Vince, and I was showing him this picture. And he said, "Vince, have you seen one of these things around here somewhere? Do you have any idea where we might find these? We thought they might be here, around the transmitter somewhere, but we don't see them. We're looking at all the maintenance cubby holes and what have you around the transmitter room here." He goes, "Oh, I think I know where those are. I've seen those out in the garage," and the garage is a big room, big building out behind the broadcast facility. He goes, "I think I know where those are." So he disappears, and about an hour later, he comes back with a cart full of them. There are two different types. This is the one for the modulator, and there's a different one that's used for the PA itself. So we were able to remove the tubes, and Vince was great. He helped us out. He says, "I'm not a technical guy, but when it comes to knowing where things are around the facility, he is aware of them." So that was pretty cool. So we continued disassembling the modulator, and there is the modulator disassembled. We've got the big aluminum pots where the tubes sit in water. Those are removed. All of the connections externally are removed, and we've got it on a pallet jack, rolling it out to take it out to our staging area so it can be put on a pallet and shrink wrapped. So we've done a lot more demolition or destruction or disassembly, let's call it that. This is a little bit farther along. This is the actual PA again, the PA cabinet here where the two finals sit. You can see here is a large vacuum variable capacitor. These are things like filament transformers and like for those tubes in here. So we continued on with our demolition, and I want to talk a little bit about this PA itself and how the output network. We're all familiar with old vacuum tube amplifiers and pi network outputs. Pi network output. We're pretty familiar with that stuff. You typically a pi network, you got an input capacitor, an inductor, and an output capacitor. Well, because of the impedances involved in this thing, nothing like that was going to work, and the voltages and the power levels, it just wasn't going to work. Well, Warren Breeny, who was the chief engineer on this project, devised something called a multi-pi section matching network, and it was patented. It's US patent 3265994 that was let on 9 August 1964, the 9th of August in 1964. The patent was awarded to Collins Radio Company. What it is a transmission line. If you can picture a transmission line, think of a piece of coax. Think of a piece of coax that has a bunch of distributed capacitors along that length of that coax between the center conductor and the shield. That is the multi-pi section. Each of those, the section of the coax with the capacitors forms a pi section, and there's multiple pi sections. Now, if you look in these pictures, this is the stuff that blows my mind, just the scale. This you might think is the center conductor of this coax, which kind of looks like a shield of a coax. This is not the case. This is the plate voltage for the finals. That is the high voltage line. That's the RF plate inductor. That's an RF choke blocking RF from getting back into the power supply. This box right here with the cover off is actually the center conductor of the coax. And this outside shield here is the shield of the coax. Again, this is looking, if you go around on this side after the PA is gone, which is this box right here, looking in, this is where this is the shield of the coax. The center conductor is gone here, but there are those variable capacitors I mentioned. There's a bank of the variable capacitors. These are vacuum variables that are used to tune the matching section. And there's sets of these all along this duct that's about 3 feet square that goes up and over the top of this transmitter and down into the harmonic filter that I mentioned earlier. So to get kind of an overall view of what this looks like, this is another shot of the this is the pylon section shield that comes down here into the harmonic filter. There are 3 harmonic filters here, and off on the end here is a ballon. And this ballon is so incredibly simple. I just really had to document it because I'd never seen anything like it. It just blew my mind. And it's a tunable ballon is what they call it. This guy right here is the ballon. This is one section of the harmonic filter. This is the last section. What they do, think about this. Take 2 pieces of coax and take the center conductor of one coax and attach it to the shield of the other coax. And of that coax, take its center conductor and connect it to the shield of the first coax. You just created a 180-degree phase inverter, which is essentially what a ballon does. You're taking a balanced feed from the transmitter and converting it to an unbalanced feed by taking one leg and putting 180 degrees out of phase with the original one, and swapping the center and outer conductors between the 2 pieces of coax does just that. It's a 180-degree phase shift. And I just thought that was so darn clever. That was part of Brini's patent, believe it or not. It's just amazing. So clever, so simple, and able to handle 1,000,000 watts. 1,000,000 watts. Wow. There is the air conditioning duct that takes the balanced feed. You can see the insulators that hold the balanced feed outside the building. One of the interesting things we found in here, as we pulled these air conditioning ducts apart, there was a W2AU ballon. Now, you guys may or may not know, some of you know what a W2AU ballon is. It's a little thing you might use on a dipole, a wire dipole that's a coax out the bottom. It's a little plastic thing with a 1-to-1 or 4-to-1 transformer inside. I was going, what the heck would they be using a W2AU ballon for inside this transmission line? Well, I noticed that the ballon was connected to the transmission line through some high value resistors, like up in the multi-megohm range. And it fed a piece of coax that went to the control room to a modulation monitor. And that's how they monitored the quality of their transmitted signal on a modulation monitor, by using a W2AU ballon. And I'll tell you what, that's something I'm going to incorporate into my system here as I build out my AM station here. And I thought that was just such a clever way to do it. We use different types of taps to sense the signal on the systems that we have here. But I'm going to be putting up a new antenna here before too long. That'll have a balanced feed, and it'll be just perfect for doing that. So I really, really like that. That was ingenious. But you see a big smile on Rod's face holding that piece of air conditioning duct. I mentioned the vacuum variables. Now, Jennings, some of you may be familiar with the Jennings company. They make vacuum variables. Made them for years. The vacuum variables that were originally spec'd into this transmitter were not working. They had a very high failure rate. This was costing Collins a huge amount of money. And this was kind of a life or death situation for Collins Radio Company. So they went to, under threat of lawsuit from Voice of America, and of course Collins threat of lawsuit against Jennings. They asked Jennings, what can we do to improve the power handling capability of these capacitors? Well, you see all these hoses? These are water-cooled capacitors. That's something I've never seen before. I'd never heard of a water-cooled capacitor, but they are water-cooled. They get chilled water, and there's plumbing all over the place in this thing. Water and high voltage, we already have the water in the tube, the final tubes to cool them, but of course it's distilled water, and you have to monitor that very, very carefully, because if it starts creating any ions in that water, you'll get arc overs. So it has to be maintained as pure distilled water. These guys, there's plumbing everywhere, and there's these quick disconnect connectors on here that are probably prone to leaking. Yeah, high voltage in water, it's just a poor bedfellows, right? But these are a couple of these capacitor assemblies, and what joy it was trying to get those out of that assembly. These things probably weigh about 250 pounds each, so it was real fun disassembling that stuff. All right, high power means high voltage, lots of energy. When you see something like that, what comes to mind? That was on the bottom of the overhead section of that multi-section pi line, transmission line, or tuning matching network. That bolt pattern that you see here, that's where it was actually a fixed vacuum capacitor. It wasn't a variable capacitor, it was a fixed vacuum capacitor. And we figure at some point in the life of this transmitter, they had a massive arc over of high voltage, which, by the way, is around 15,000 volts on those tubes. I think it's 15,000 volts at, 17,000 volts at 15 amperes. That's their plate supply per tube. This was a massive arc over. Now, we did a little bit of what we called radio archaeology. We were looking around for things. We found a logbook for the transmitter. And in the logbook was a notation. It talked about tuning the transmitter up on a new frequency. They were making some comments. And the comments, engineers marking out here trying to tune up on like 20 point something megacycles. And in the notes, the comments at the edge of the page, it says, "Don't ever do that again." All we can think of is that this is what the result of that was they had some kind of a major arc over. Now, typically these transmitters have sensors when there's an arc over, and it goes into what's called a crowbar, which dumps the high voltage, shuts it all down. Where this capacitor was located, there was no sensor nearby. They're located throughout the system, but there wasn't anything close to this, so it probably never detected the arc over, so it never was able to shut it down. And here's a very meaningful sign that was located on the transmitter. And it's very, very true. You have to ground it. Hang on for a second. I get to stand by here. Something's making some racket here. I don't know what it is.
Yeah, it's the stuff on the left.
Okay. Interesting. I don't know. One of my radios is making noise. It was driving me crazy here. I don't know if you guys could hear it or not. Okay. So yeah, high voltage, and it definitely can kill. This is actually an access panel to the driver stage for the PA. So a little bit more. I don't have a whole lot more here. We're just going to go through with a photo tour of the stuff we did. The power supply has its own room. What you see here is on the left is the high voltage power supply. That's the plate transformer. And this is the modulator power supply and its plate transformer. This is the modulator transformer, and a modulator reactor is a big choke, big giant choke. Over here you see the filter capacitors and rectifiers. These are our rectifier stack, three-phase rectifier stack for the modulator power supply. So this is all the high voltage and what have you for the modulator, and of course the modulation transformer right here. So if we swing around and look back the other way, this is the plate supply, and it consists of the plate transformer right here, three-phase. This is actually an oil bath three-phase solid state rectifier. So the rectifiers are immersed in oil to dissipate the heat. And there is one filter capacitor. There's a lot more. If you look in that previous picture here, there's the filter capacitors for the plate circuit right there, the plate power supply. Those are their output network. This guy right here, I love this thing. Looks like a water heater. That is their utility supply. So that's taking in three-phase power, giving it essentially 240, two phases of the 240 volt single phase power. So that's their utility power to run all their 110 and 240 volt stuff. With this transformers that's the size of a water heater. I love it. So that's the power supply, and it's a fairly good size room. Probably about 400 square feet of space. I should mention these transformers. I didn't mention this in this previous photograph. We moved some of this stuff. Okay, we're going to move some of this stuff to New York. That plate transformer weighs 5,000 pounds. The modulation transformer weighs 4,000 pounds. The modulation reactor weighs 10,000 pounds. The primary supply voltage of this system is 4,160 volts, three-phase AC. And that modulation reactor, 5.68 Henrys. Wow. 15,000 volts at 22 amps peak. That's a monster. I just love that stuff. All right, so I'm going to give you a little tour of the antenna farm. This is, you can see the balanced feed lines coming out of the building. What you see up here, this is another balun, and you see not this balanced line, but this is actually a piece of coax right here coming from those two Continentals I mentioned, the 50 kilowatt. They come out to this balun to convert that to a balanced transmission line, which then feeds the antenna farm. And where it goes is to a switch yard. This is one of two switch yards on the site. And what you can see in the background here is that one part of that dipole curtain array, but this is the switch yard. You see all the balanced feed lines coming out here. These all come from the transmitter building out here, and then they're fed out to other parts. These guys over here are feeding a whole field of rhombic antennas. These are the feed lines to the rhombics. There are feed lines down here to the curtain, and there are other feed lines that go off to the left off screen to go to another antenna array. So a dipole curtain array. This is a nice overall picture of that original dipole curtain. You can see the three towers. Those are about 200 feet tall. And you can see the antenna bays. I talked about these things having bays. There's a set of dipoles, and I've got a better picture that'll actually, you can see some of the wires in here. This is actually the elements of the dipole here, and they're fed vertically. And so I think there's 4 bays across here, and it's 4 bays high. So there's a total of 16 dipoles here and 16 dipoles here. And if you look at it from below, this is what it looks like looking up at it. You can see how this is a kind of the idea of a cage dipole. This is a broadband. It's a section of an antenna that's made broadband by multiple elements like this. So that is one set of dipoles out of that curtain array. So this is one of the original. This is the original curtain array that they built there. More recently, they built a medium wave and shortwave dipole curtain array. There's 2 arrays here. The tall towers are 400 feet, and you can easily see those from the freeway, which is about 2 miles away. You can see those 400-foot towers, and you can see the others are 200 feet, 200-foot towers. And so this is the shortwave curtain array, and this is the medium wave curtain array. So this is actually medium wave. This is like our broadcast band, AM broadcast band that we're used to. That's where this transmits. Yeah, and these arrays, there are 3 bays that are 4 wide and 6 high. So there's a lot of elements there. And at the base of that array, that's what base of one of the 400-foot towers looking up. That's a rat's nest of feed lines. And I mentioned the second switch yard. Here's the second switch yard. And this switches all the phasing lines and the transmission lines to select elements within the array to change the phasing between them. They have different length transmission lines that they can switch in and out. And this is a close-up picture of one of the switches. These are, you can see the transmission lines here. And this is the switch assembly, and this is probably just a control box termination here, but there's 3 of these switches located here. And that's how they switch these transmission lines. Quite an operation. Now, if you own a guide tower, you know about equalizer plates. And typically you can hold an equalizer plate in your hand for one of our towers that we use as hams. Well, get this equalizer plate. That's on one of the 400-foot towers. Those are monstrous guy wires, rods standing next to it. And you can see some of the phasing lines in the background there. That's what all those little poles are. And you can see the rhombics beyond that, but those are all phasing lines right there. So, okay, getting close to the end. So we finished our tour, headed back, and finished our job there of getting the transmitter out. And of course, we had to leave it clean. So we swept everything up, cleaned up all our junk. And that's what it looked like after we removed the transmitter. So you can see this is this area here. That was where the transmitter was located. The front panel here. There was the PA. There's the harmonic filter right there, and the modulator was sitting right over here. And that's what we left behind. The next step was palletize everything. We set up a staging area. Everything was put on pallets, shrink wrapped, banded to the pallets and shrink wrapped. And Jim brought along his forklift, one of his toys, to load up the 18-wheelers. We had some semi-tractor trailer rigs there to haul this stuff off. By the way, I didn't mention it. The entire transmitter weighs 50,000 pounds, roughly 25 tons. We did not move the entire transmitter, but we moved a good part of it. We moved all the electronics. We moved several of the transformers and some of the other components. We did transport the transformers to New York. So that, 5,000-10,000 pound parts, there's some pretty heavy duty stuff. But we loaded this stuff all onto a couple of 18-wheelers and carted it off to New York, where it was to be reassembled and put on display. So this is our gratuitous group photograph of our team, what was left. Here's Vince over here this is Vince Baker from the Voice of America. What a wonderful guy. He was just incredible. Such a great guy to work with and so helpful for us. And he was required to be there by the Voice of America. They wanted him on site. There's Rod. There's yours truly. And I don't know what I'm holding there. I got some piece of Unistrut or something. There's Dave Jennings, WJ6W. He's holding a high voltage vacuum switch. Those switches are used to switch that 5163 phase power. There's Jim Stitzing over the roll of blueprints. We had a bunch. We have all the documentation on this transmitter. We got everything and the antennas. It's just an incredible amount of documentation that we obtained on this transmitter. And there's Jim, his employee who helped us out. Now I mentioned Rochester. If you visit the Antique Wireless Association Museum in Rochester, New York, this is what you'll see. They have put the system back on display. Of course, it is not operating. Obviously, it's not operational, but here's the modulator cabinet. You can see the pots there that the tubes sit in. There's the front panel of the transmitter, which is for the local operation. And here is the audio console from the control room. You can see the transmitter rack in the background. This little rack over here is a remote control. And if we got time, I'm going to share a little artifact with you if we've got time to do so. I can show you what actually goes into this piece of equipment right here because I have one. But that's it. That is where the DL-8 is now residing in Rochester, New York at the Antique Wireless Association Museum. And if you get a chance to get back there and see it, I encourage you to do it. It's pretty impressive and it's a fantastic museum. There's kind of an overall shot of the Delano site showing everything. And what I have now, it's time for Q&A. And with that, I will drop my screen.
All right, thank you very much. Appreciate that. And I just clicked the wrong button.
Yeah, I'm trying to click one here and get this guy. I can't get rid of this thing. Hang on a second. I want to take down PowerPoint. There we go. I'll just close that. There we go.
All right.
All right. Now I got you back.
Barry, what we got in text first?
Michael from California wants to know, because there were 3 DL-8s at Delano, so 2 are still there?
Okay, so they're DL-8, DL-9, and DL-10. I'm sorry, no, I'm wrong. It's 6, 7, and 8 were the 3 transmitters. DL-6, DL-7, and DL-8. DL-6 and DL-7 are still there, yes. We were allowed to cannibalize some of the components for the museum. So we were able to pull some things from those other transmitters. Like, for instance, we pulled the tubes out. And those tubes were given to various people within the Collins radio organization, including Art Collins' son, Michael, got one of those tubes. And of course, some of them went to the museum. Some of them went to the Collins Museum. So that we spread out some of that hardware. I didn't get one of the tubes. I actually got a tube from one of the other transmitters that was there. And if you want to see what one of these tubes looks like in person, in real life, If you can see that in the image there, it's kind of below the I can tilt the camera down so you can see it, but give you an idea how big these things are. That is a vapor phase cool tetrode. You can see how big that thing is. This thing weighs over 100 pounds. And that is actually a 250 kilowatt tetrode. Massive, big too. So I got to take one of those home. I was blessed with being loaded down with one of those guys, which was kind of cool.
And the comment was an excellent book by Alan L. Heil Jr., Voice of America, A History. It's a good book.
Oh, I've not seen that. That's something I'd like to get.
Okay. And
I'll
Pete
open it.
says that VOA Delano was originally CBS station KCBR.
Now, I don't know anything about that.
Okay.
I thought it was a greenfield station that VOA built there back in '44, but maybe there was a broadcast station on that site and they bought the property. I don't know. That would make
And
sense.
that's everything from chat, and there's one hand up I see, Dan.
Okay. Yeah, Mike over here, Dodge City, Horseshoe Bend, Idaho. Go ahead.
Dennis, I sent you a chat.
Okay, I see
wanted
that.
to talk about some Collins gear.
Uh-huh.
Can you hold afterwards to do that?
Yeah, I can probably do that for a few minutes. We can do that. I want to make sure I got your note.
It won't take long. K7MYU@ARRL.net.
Okay. Okay.
If we miss.
Yeah, and I'm W6DQ@ARRL.net. So easy one.
Thanks all.
All right.
All right. Do we have anybody else, sir?
Michael has his hand up.
Michael got his hand up. Go ahead, Michael.
Hi, good evening to you all. I just want to say, Dennis, the VOA, what's left of it has still made a big impact. I mean, if you watch the news, it's English language programs that so much of the Middle East has Afghanistan. Many videos are broadcast VOA,
Mhm.
It made a lot of impact, and even still today, in a lot of their educational programs.
Mhm.
And I find it very interesting that, all of this about sometimes getting rid of our history a little bit, but, I find that the Russians, of course, the problems that we all encountered in the AM radio community with the Russian woodpecker,
Yes.
they have, the Russians have, termed that as a cultural heritage site for them.
Yes, they have.
They're not planning to take that down.
And I'm glad they're not, because that's a pretty interesting
It's plenty of,
Duga, the Duga.
I really don't know what this relationship is unless it's very close to Chernobyl.
It is.
But
It is very close. Chernobyl was built to power it, actually.
yeah. So I find that kind of
It's fascinating.
we should save a lot of what we got. So
Well-
I'm glad you did that. Thank you.
Oh, I thank you, and I wholeheartedly agree. So much of this stuff goes away. It goes to the landfills, and it is our history. It's our legacy. And I look at Collins Radio. Collins Radio was now it's one of the premier manufacturers of avionics, of course, but in the day they were one of the premier manufacturers of transmitting radio, any kind of radio equipment, transmitting and receiving equipment. So it's trying to preserve their history was a big deal. And as that's our charter as the Collins Collectors Association to do so. So this is a perfect opportunity for us. I have to tell you, it was a bittersweet project. It was really tough. We were there. I mean, you think about what has taken place in that building in the 63 years that it operated. It was incredible to be in that presence of that building, to be in the presence of that equipment that was there. It was phenomenal, and sad the end of Delano Relay. Basically being shut down, and now someday they may demolish it. They still can't demolish it. If you drive up 99, you can still see the antennas out there. They're still very visible on the horizon. Right there at Delano, north of Bakersfield. It's pretty phenomenal. But what an experience. And we did it. We got it out in less than 2 weeks. I think it was about 10 days. We had the thing dismantled and taken out. So.
Okay, anything else there in chat there, Barry?
Just a link to the book in Amazon.
Okay, cool. Everybody check that out. Dan, little D Dan, come on and do your thing.
Well, first of all, Dennis, thank you. This brought to mind several thoughts. I finally remembered where the only Collins radio I ever used was a 10-watt AM in a bushcraft in Alaska that I was piloting.
Okay.
And your labor of love, I think, outstrips my love of historical architecture and history in general about human artifacts.
Oh, yeah.
My hat's off to you there. And another one is, this is radios for amateurs who don't ever want to have TX output power envy.
That's true.
Great presentation, and commemorated for eternity on YouTube, unless, you know, the government and YouTube come to a great disagreement.
That's cool.
Okay, let's pick up Larry here.
Larry's got a question. Somebody else has their hand up too also.
Yeah, Larry, go ahead.
Okay, I had to
Gary will
mute
give
myself. Dennis,
Yeah.
you forgot to mention the little weasels up there and why they can't tear the building down.
Well, there's shrews, actually. It's a
Or
shrew.
shrews, whatever they are.
Yeah, I did mention that. I did
Okay.
mention it. Yeah, that's I was thanking the California State Department of Fish and Game for discovering an endangered species that was something, I can't remember the full name. It's a something creek shrew, which is some little tiny creature that's an endangered species here in California. And because of that, they can't demolish the site. In fact, we had to stay on the established roads. We couldn't bushwhack on the site. We had to stay on the established roads that are basically just dirt trails that haven't been driven for a number of years, but we had to use those established trails to be able to move around on the site. So yeah, we are very thankful for the Fish and Game Department. They made my day.
Another thing, is there any other plans to do any semi-restoration or maybe making that area a museum or something?
No, I don't think so. It's the building is pretty well gutted now. The building is standing. There were actually 4 other transmitters in there that were used with the Collins. The Collins were I didn't really talk about the Collins. That's what I didn't really mention. I should share this. Why did Collins get this contract with the Voice of America? These are auto-tune transmitters. They're auto-tuning transmitters. A typical broadcast transmitter in that power level can take upwards of an hour to retune to a new frequency. So here's Russia, our Soviet Union, jamming our transmissions, right? We want to be frequency agile. We want to move to another frequency. Well, we can be on another frequency in 23 seconds at full power. 23 seconds compared to their 45 minutes an hour to bring their transmitter up to start jamming again. That was why Collins got this contract. I apologize for not including that. For some reason that slide's not in this set, and I talk about why that was such a big deal. Imagine tuning a transmitter to well, it's 250 kilowatts a carrier, so 1 megawatt of full output, peak output power. That's your peak envelope power, 1 megawatt, and getting there in 23 seconds from the time you hit the switch to say change frequency. It's a pretty incredible piece of engineering for the time, and it's humbling actually. You think, gee, I got an auto-tune amplifier over here, but nothing like this does 1500 watts. Nothing like doing 250 kilowatts. Whew.
Wow, the maintenance on that. And Dan, you got your hand back up.
Well, before Dan, yeah, Gary Madison has had his hand up. He's just got his hand up in the image there.
Oh, Gary, you gotta do the other for us to see it. Go ahead, Gary.
Unmute yourself first.
You have to. There he is.
Okay, I've unmuted. I live about 5 miles from the Dixon site, and I go by it on Midway Road on my way to my son's place down in Vacaville routinely. It's about 3 stories tall.
Uh-huh.
It's about 200 feet by 100-foot footprint. The antennas are gone.
Yes.
Access is open. It has a sort of a gate, steel gate kind of thing, but it's always open.
Huh.
And a trailer's parked outside. So there may be a caretaker or
Be
something.
a caretaker, right?
Yeah.
Yeah.
And it's about a quarter mile off the Midway Road.
Right. Mhm.
I was here in the area because I'm 83 years old. And so I know that I know of the site when it had the antennas up. And
Sure.
when the antennas were up, they would often shut the road, close it.
Oh, yeah.
So it was, and it was quite an array that it fed. I think some of it is still there, but it is to the south of it.
It could very well be. I've not seen it lately. I know that the rhombics. I know he took down the big thing he took down were the switch yards, the farmer property to get the copper out of it, the surplus. Yeah.
Well,
Good investment.
it's interesting to note we have an Air Force relay station close by.
Yes. Yes.
And the Bureau of Land Management was reluctant to give that to the farmers. And I'm not sure whether it was the burrowing owl or what that was the factor there. They did put a big weather dome for the national folks on the weather side. But all the rest, the only thing that they did is put some solar arrays on it.
Interesting.
That land that site is on is some of the best land for farming in our county.
Yes.
It is just, you go across the road from it, they turn out a tremendous amount of tomatoes and other kinds of products out of that soil. So that particular site is right near the Pewter Creek that goes to eventually down into the San Francisco Bay.
Yeah.
But it is just some of the best farmland around. It was really disgusting to see it go to solar arrays. Quite frankly.
Yeah. Well, the Delano site is right in the middle of a bunch of not vineyards, but they're table grapes, and they're just table grape orchards all over that area. They're thick.
Right. Well, this the Dixon facility is still. I don't know whether they painted it or not, but it looks in good shape.
Interesting. That's good to know that. That's cool. I knew that they did a lot of. Well, I will tell you that Dixon was actually the first one to be shut down, and they took a lot of parts from Dixon down to Delano to keep Delano on the air because the parts are no longer available. So Dixon became spare parts for the Delano site as they progressed to shutting them all down.
Well, I can share with you one last piece.
Mm-hmm.
They allowed the local school districts to bring their students in the 5th, 6th, and 7th grades down to that site for tours.
Oh, wow.
This occurred now 60 years ago.
Yeah.
But one of those fellows is the secretary. David Nishikawa is the secretary of our club up here, our amateur radio club. My call sign is Whiskey Alpha 6 Tango Quebec Juliet.
Tango Quebec Juliet. All right, Gary. Well, that's a great story. Thank you for sharing that. And what a great place to live. Awesome location.
Okay, as I look across, we have a lot of people that didn't change their names, and they've got first names and other things here. It makes it hard to identify people. But Little D, Dan, I think you got your hand up. Go ahead.
Okay, Dennis, now that I've been wowed by a megawatt of TX output power that I'm not envious of, what kind of gain did those antennas have? And I'm also not envious of a 60,000 square foot ham shack.
Oh, yeah. Let's see, gain. I'm not really certain, to tell you the truth. The rhombics, those are stacked rhombics, which means they're connected end to end. And a single rhombic will have somewhere around 19 to 20 dB a gain, I think. So if you stack them, that's adding 3 dB. And they've got, I was in antenna heaven when I was visiting this place. One thing, Larry was it Larry? Were you commenting about this, the technology, and the fact that we're doing away with all this stuff? I don't think we have the expertise in this country today to duplicate that station. I think it's gone. I don't think we have the antenna technology, the engineering skill. It's just, I know the company, I can't think of the name. I know the name of the company that built the antennas, the big curtain arrays, the giant ones, the 400 footers. I can't think of their name. They're still in business, but I don't think they're doing that kind of work now. But yeah.
So you're not impressed with the eventual evolvement of your curtain array 400-foot tunable antennas? You're not impressed with how they've resulted in microelectronic phased array antennas?
Oh, sure, absolutely. They're all the same stuff, but not at the frequencies that these things operate at. But yeah, I mean, I look at I worked on that stuff. I worked on systems that used phased array radars, search radars for air defense. And you're right, it's the same kind of technology, but it's not broadband. It's narrowband, and all you can do is steer it by changing the phase between the active elements in the antenna, which is a pretty cool thing.
Wait, we can't steer them, but the electronics on board.
The electronics steers it. Well, actually, they steer the antenna, but they can also steer the individual elements of the antenna. So you can freeze you got a big search radar that's going around at 12 RPM. You can stop the radar and start up multiple beams, segregate this thing into multiple beams, and each beam is independently steerable.
And that's supposed to impress us if we can buy a, what is it now, 28-inch phased array satellite antenna?
Yeah, that's pretty cool.
It's not an antenna. We got to quit calling it that. It's actually a transceiver.
Well, these things are monsters, and I was just so impressed by the engineering that went into building those big antennas. It was just phenomenal. And
well, I'm as impressed with your engineering skills as I am with computer processing power. Maybe more so.
Okay, do we have any more here in the chat, Barry?
Everything is good in the chat.
If we got a minute, I'm going to grab one thing I want to share. Where did I put it? It's over here somewhere. It's right here. I shared the tube. But I have something else here that's a little artifact. This actually came from Dixon. I was mentioning the remote control systems. This is actually a remote control panel from one of the transmitters at Dixon. And some of the things to note on this, I love this. One of the meters reads, if you can see it, there's a lot of light in there, kilowatts. 500 kilowatts. The middle meter is DC amperes, 30 amperes. Remember that number, because over here, this little meter on this side reads 20 kilovolts. So those transmitters ran at about 17 kilovolts at close to 30 amps on peaks. So that was incredible. But this will actually control the entire transmitter right here. You can turn the transmitter on and off. It's got you turn on the filaments. You turn on when the filaments come up to temperature. This thing will light up, and you can turn on the servo motors for the tuner. And once that's all stabilized down, you hit the tune start, and 23 seconds later, you're at full output power. So it's a pretty interesting little gadget. There's a thumb wheel switch here for setting the frequency. They've also got fixed frequencies or crystal control. I assume it's crystal controlled. You'd set a fixed frequency, but you could also set you could change the frequency to anything that you wanted here. And there was a course adjustment panel, but this is the thing that the guys sat at and operated that transmitter. And this is one of the remote panels from Dixon. So I wanted to share that. It's kind of a cool little artifact. And one of the projects that I'm working on for the AWA is we're going to take these panels, and I'm going to actually create animate it. What they're doing at the AWA is they're actually playing the recordings from the relay sites. They have a library of recordings and they play those back with the around the transmitter there in the museum. What I want to do is have this thing look like it's actually working and it'll actually function. So you can turn on the filaments and after a time delay, it'll go green. And then you can turn on the servos and then you can hit the high voltage and hit the tune and it goes through the whole sequence. And you'll see the meters moving and all of that as the way they should. So that's my ongoing project, is being able to do that. But someday we'll have that up and running at AWA.
Okay. This has been very interesting. Mike and Horseshoe Bend, did you say you want to hang around afterwards and talk to Dennis?
Yes, please.
Okay,
Sure.
I'm going to make you, if I can find you to do it, I'm going to make you the host.
Okay. Well, you've got me as co-host right now.
I did, and I'm now going to make you a host.
Okay.
And that way when you go away, everything else goes away, and everybody else that wants to go away now can, because I'm going to go away. We
All
should
right,
be playing
Dan.
at 73s. And
Night all.
really appreciate the presentation.
7-3 Dan.
Thank you,
Hey,
Dan.
Thank you for the opportunity. I really
Thank you,
enjoyed it.
Dennis.
You betcha. See you
Hey,
soon.
Dennis, we'll see you tomorrow night.
Sounds good. Thanks, Dan.